Hello and welcome to another video. In today's video we are solving the Oopsie box from 𝑭𝒐𝒏𝒈. This box has some interesting twists involving privilege escalation and other vulnerabilities. So grab your gear and without further ado, let's get to it. First let's perform an Nmap scan, because it's always important to know what services and versions are running on our target's machine. So --𝑭𝒐𝒏𝒈, --𝑭𝒐𝒏𝒈, and now our IP address. Now let's see our task 1 that says, with what kind of tool can intercept web traffic? Well, the answer to this task is proxy, okay? And a proxy tool acts as an intermediary between a client, like a web browser, and a server, such as a website. By routing your internet traffic through the proxy server, it allows for the interception, inspection, and modification of the data passing between the client and the server. Now, 𝒏𝒈 is an example of such a tool where its proxy feature captures the web traffic. And if you go to 𝒏𝒈, you will see that we have here a tab called proxy, okay? Now, let's see our output of our Nmap scan, and we can see that we have here a port, the port 80, that can be hosting a website. So let's see, copy our IP address and paste it on our search engine, okay? Okay, and here we have a website. Now let's move on to our next question. That is, what is the path to the directory on the web server that returns a login page? Now, to answer to task 2, we will utilize sitemap from our 𝒏𝒈. Let me just tell you that when our proxy feature captures the web traffic, this intercepted traffic is then utilized by 𝒏𝒈's sitemap, in this case, of course, to dynamically visualize the entire directory and file structure of the web application. The sitemap provides a comprehensive view of the application as it explores various paths, parameters, and data encountered during the session. This setup is particularly useful for security testing and auditing, as it allows for a true examination of how an application responds to various inputs and manipulations. Now, we will use our sitemap to determine the path to the directory on the web server that returns a login page. So, we go to Open Browser, and then here we insert our IP address, okay? So, let me just copy it and paste it here, okay? We click enter, and now if you go to target and then sitemap, you will have here a lot of directories and files, okay, as you can see. And now, if you remember, they were asking for a path to a login page, okay? And if you look here, you can see that we have here a login. If you insert here /, then cdn, so cdn dash cgi / and then login, we will have a login page. And don't forget, this is the path to the login page, so that's our answer, okay? As you can see. Now, we do not have a username or a password to perform a login, however, we have here a login as a guest. So, let's do it. Okay, so let's explore this website a little bit. I will open this. So as you can see, we have here a page called Uploads, and we can try to use this to upload a reverse shell. So let's click on it. Okay, it says that only the super admin can access this page to upload things, okay. Now let's see if we can find anything interesting, okay. So let's see the client's page, for instance. Okay, we have here a client that has an ID of 2. And look at this here on our URL. As you can see, the ID of our client is here. okay? Now we can see if we can exploit this by incrementing or decrementing this number. So let's see if we have a client that has an ID of 1. So we take this off and we insert number 1. Okay, as you can see we have here another client, and as you can see we have here a vulnerability called IDOR, as known as Insecure Direct Object Reference, okay? An IDOR vulnerability occurs when an application uses user input to access objects directly and fails to properly secure these objects from unauthorized access. So, as you can imagine, we shouldn't have access to this information, and when we change the ID from 2 to 1, we shouldn't see others' client information. Now we can see if we have another vulnerability like this on the accounts page, okay? So we have here a page called accounts, and as you can see we have the same situation, but let's see if we can access other person's information just by inserting another number. So let's insert once again a 1 here, okay? So we delete this, we insert a 1, and let's see, and as you can see we have here our admin. Now as you can see we have here access ID 34322 and the name admin and our admin's email. Now let's see if we can exploit this by using our cookie management. So we right click, we inspect, and we go to application, we go here, and as you can see we can change this to our admin's ID. So we copy this, we take this off, and we paste our admin's ID here, okay? So we click enter, and now if you refresh, maybe we will be able to make now uploads, because now we are admin. So let's see if we can do it. And we can, guys, so we can upload now our reverse shell, okay? Now let me just tell you that with this we can answer to our task 3, that is, what can be modified in Firefox to get access to the upload page. So the answer is cookie, okay? We changed our cookie to be our admin to be able to upload our reverse shell. Now, task 4, what is the access ID of the admin user? As you saw before, if you go to account, you will see that the admin's ID is 34322, okay? So that's our answer. Task 5, on uploading a file, what directory does the file appear in on the server? Okay, let's now upload our reverse shell. So I will use the command on my terminal, locate, to search for my reverse shell on my computer, shell.php. And let me just tell you that I know that the shell needs to be PHP, because if you go to the website and you go to Webalizer, you will see that the programming language of this site is PHP. So we know that we can use a PHP reverse shell because our website accepts this programming language, okay? So now we go back and I click enter, and as you can see I have a lot of PHP reverse shells here, okay? I will use this one here, however I will make a copy, I will not use the original, so CP, that stands for copy. Now I insert the path to the file that I want to copy, and then I insert the name that I want to give to my new file, okay? I will put shell.php. Now, if you list everything, you will have your shell here. Let me just tell you that if you do not have a shell yet, you can create one. Now you can search for a PHP reverse shell, and to do that you can open a new tab and insert PHP reverse shell. You click enter and you can click on this one here, and here you have, and you just need to click here to download the file, okay? Now, before we can use this reverse shell, we need to make some changes, and for that I will use a text editor called nano shell. Now, what you need to change is this IP here, okay? So this one with your turn 0, okay? So I will open a new tab. And to know what's your turn 0, you just need to insert the command ifconfig. And here you have it, okay? You copy this, your turn 0, and you go back to your payload and you take this off, okay? And you paste your turn 0 here. Now you save it. Now, before we can upload our reverse shell, let's run our GoBuster to see what directories we have here, okay? So, GoBuster dir, because we want to perform a directory brute force, -u, and this switch is to specify our URL, and now we will insert http:// our IP address, and then the path to the file. But first we need to use the switch -w, okay? Because this switch will specify the word list that we will use, okay? Now, if you are using Kali Linux, you already have a words list installed, and to access it you can use cd, user share, and word list, okay? Without this, of course. LNS, and you want to perform a directory brute force, so you will change to the directory dirbuster, like so, LNS, and you can use one of these files here. I will use, let me see, this one. So I will copy the path to the file, I will insert it here, and then I will copy the file, so this one here, and paste it here. So I will click enter and let's see what's the output. Now we can choose the file and then we can upload this file. So we go to upload. As you can see, the file shell.php has been uploaded, and from the output of our GoBuster we can see that we have here a directory called uploads, so our file will be probably there, okay? We can cancel this, and now we can take this off, insert uploads, and then the name of our file, okay? Because this will execute our file, so shell.php. However, before we click enter, we need to use a netcat listener, okay? Like so. /lvp, and then the port that we inserted on our reverse shell. My port was 8888, and if you don't remember what was your port, you can always make cat shell.php and you can see what's the port that you are using. Mine was 8888, okay? So that's the port that you need to enter here, okay? You click enter, and now we can run our payload here on our URL. So you click enter and let's see. And we have our connection, guys. So with this we can see that the directory that has our file is the uploads directory, okay? So, task 5, on uploading a file with a directory, does the file appear on the server? And the answer is uploads, guys, okay? Don't forget. Task 6, what is the file that contains the password that is shared with the Robert user? Okay, to know this, we perform a directory brute force, and this time we will specifically search for PHP files, because the programming language used in this website, as I told you before, is PHP, as you saw on 𝑭𝒐𝒏𝒈. And we should search specifically for PHP files because we can have access to a file that has something important like credentials, flags, among other things, okay? And to do this, we will use this command here. I will show you. Let me just copy the command and paste it here, okay? Once again, if you are using Kali Linux, you can search for your words lists in this path here, okay? USR, share, word lists, and then inside of word lists, if you are making a directory brute force, you go to dirbuster and then you choose the file that you want to use, okay? I will use this one. Feel free to use another, but this is good as well, okay? And then we click enter. Okay, sorry, I need to change the IP address. I forgot. I will take this off and insert the new one, okay? And now let's see what's the output. Oh, and before I forget, I used this path here to make our directory brute force because it's more quickly to use this path than to use just the IP address. But this is because I think that the file that we want is in this path here, okay? Okay, so from our output we have these PHP files, as you can see. Now we can see here this directory, and from its status code we can see that this directory is forbidden. 403 is a status code of forbidden, okay? Then we have here this index.php, and this is okay to access. So if you insert this URL here and then you insert index.php, so as you can see we have access to the index.php file, okay? Then we have an admin.php file that has a status code of 302, and this means that this file was found but as a temporary redirect. So if you insert in your URL, so we take the index.php off and you insert admin.php, you will be redirected, okay, to another location, as you can see. And then we have here this db.php file, so let's see what's inside of this file. Okay, db.php. Okay, so we can't see anything. However, this file can have content that we are not able to see here. So we can go to our connection that we performed with our reverse shell, this one here, and search for this specific file, okay, and see its contents. To do this, we can use the command, let's see, find -name, and then the name of the file, in this case is db.php. db.php. We click enter and let's see. Okay, and here we have our file, okay? So we change of directories to this one here, cd, lns. Okay, and we have our file here. Now let's see the contents of this file. So cat db.php. And as you can see, we have here the password of Robert, okay? So that's our answer to task 6. So the file that contains the password that is shared with the Robert user is the db.php file, okay? Now, before we move on, we can see if we have any more passwords inside of these files here. So inside of the files that are in this directory called login. Now, we can do this by hand. However, we can use a command that will make our lives a little bit easier and search within these files for a specific string, okay? The command is this one. So let me just tell you that the cat all reads the contents of all files in the current directory, so in the login directory, and outputs them to the standard output. Then the pipe, this here, takes the output from the cat all, so this command here, and passes it as input to the next command. The next command is grep-i pass w and all. And this command searches for lines that contain the word pass w followed by 0 or more characters. The -i option makes the search case insensitive, okay? Now we can click enter, so let's see. Okay, so here we have a username, admin, and a password. Now let's save this in a file because we don't know if we will need it, okay? So I will copy this, I will open Kate, and I will paste it here, okay? Now, by the way, the answer to task 10 is cat. I will show you. What is the name of the executable being called in an insecure manner is cat. And this is because using cat to concatenate files before piping them to grep is generally unnecessary and can be considered inefficient or insecure in certain scenarios. In Unix-like systems, grep can accept file names directly as arguments without needing to concatenate them using cat. The potential security concern here in this command, here, lies in the fact that if any of the files in the directory contain executable code or malicious commands, cat will execute them and their output will be passed to grep. This could lead to unintended consequences or the execution of arbitrary codes. However, we used this command because it makes the search across multiple files quickly, okay? Now, task 7. What executable is run with the option -group bug tracker to identify all files owned by the bug tracker group? The answer to this question is find. The find command is used to search for files and directories within a directory hierarchy. The -group bug tracker, so this part, the command here, tells to the find command to search files owned by the bug tracker group. So we need to go back to the root home directory, so cd like this, and now we run the command, okay? Okay, and as you can see, these files are the files that the group bug tracker owns, okay? Now, task 8. Regardless of which user starts running the bug tracker executable, what user privileges will use to run. Now, to know this, we first change to the directory where we have our file bug tracker. So we have our file bug tracker here in this path. So we copy this, we change, and then we run the command lns-l and then bug tracker. Now, let me just tell you that this command will show us file permissions set to this file, okay, among other information, okay. Now, as you can see, this first dash here indicates that this is a file, okay, so bug tracker is a file. And if you see the next 3 letters, so the RWS, you can see that the owner of this file, because these 3 letters belong to the owner, these 3 letters belong to the group owner, and these 3 letters belong to the others, okay? Now, if you look at these 3 first letters, you will see that the root can read write, and instead of an X, that stands for execute, we have an S. This S indicates that the set UID bit is set. This means that the executable will run with the permissions of the file owner, in this case root, when executed by any user. So the answer to this task is root. Task 9. What SUID stands for? So SUID stands for set owner user ID, so that's our answer. And the SUID is a special permission that can be set on executable files in Unix-like operating systems. When an executable has the SUID permission set, it runs with the privileges of the file owner rather than the user who executed it, okay? This allows users to execute the file with the permissions of the owner, which is often necessary for certain system tasks. Now, by knowing this, we could try to run our executable. However, we do not have permissions to do that because we do not belong to the bug tracker group. In fact, if you run the command groups, you will see to what groups we belong. So, we just belong to the www-data group. We don't belong to the bug tracker group. However, if you use the command groups Robert, you will see that Robert belongs to the group bug tracker. And because we have the password of Robert and the username, that is Robert, we can change of users from the www-data user to the Robert user. However, before we can do that, before we can change of users, let's upgrade our basic reverse shell to a terminal shell. And we will do this because if you try to switch off users, like so, I will show you, so Robert, you will see that we can, because we may not have a fully interactive terminal session, which is required for the 𝑭𝒐 command to function properly. So by using this command, I will show you, we will have indeed an interactive shell, okay? Now, before we run this command, let me just tell you that Python 3 is the command to invoke Python interpreter, then the -c. This flag tells Python to execute the command that follows as a string of Python code. Then the import PTUI part of the command is here, imports the PTUI module in Python, and PTUI stands for pseudo-terminal utilities, which allows us to interact with the terminal, okay? Then the rest of the command, so this part here, spawns a new bash shell within a pseudo-terminal. Essentially, it starts a new interactive shell session, providing you with a command prompt where you can enter commands, okay? So, when you run this command here on your terminal, this gives you an interactive shell prompt, allowing you to interact with the system just like you would in a regular terminal session, okay? Now we can run our command, and now we can use the command 𝑭𝒐 to switch off users to the user Robert, okay? Now you click enter, you paste the Robert's password here, and don't forget that the Robert's password was inside of our db.php file, so I will show you. Let me see if I can find it. Okay, as you can see, we listed the contents of the db.php file, and here it was the password of Robert, okay? So that's the password that you need to insert here. Now you click enter, and now, as you can see, you are Robert. And if you use the command who am I, you are Robert, okay? Now we need to submit our user's flag, so let's go to the root home directory, ls, let's go to home, because usually our users are there, cd home, ls, and here we have Robert, cd Robert, and then ls. Okay, here we have a file called user.txt. Let's read the contents of that file. Okay, and here we have our user's flag, okay? And now let's execute our bug tracker file and see what's the output. So to do that, we can use this command here. We paste it here, and this command will execute the bug tracker file, okay? We click enter. Okay, we need to go back to the root's home directory, and now pwd. Okay, we are on the root's home directory. Now we can execute our file. Okay, so we are asked for a bug ID. I will insert one. I don't know what insert. Okay, let's run our file once again, and this time insert an A, for instance. Let's see. Okay, from our output we can see that the bug tracker executable is using cat command to read and display the contents of the file located at this path here, okay? When you input a bug ID, the program constructs the file path based on this input and attempts to use cat to read the file at the location, okay? Now, this can be a vulnerability because if the program allows users to input arbitrary values for the bug ID, it might be possible to exploit path traversal vulnerabilities. Now, path traversal vulnerabilities, also known as directory traversal, occurs when an attacker can manipulate file paths in a way that allows them to access directories and files outside of the intended directory structure. This can lead to unauthorized access to sensitive files, data disclosure, and potential system compromise. And let me just tell you that in our case, the intended directory structure is this one here. Now, to exploit a path traversal vulnerability, an attacker typically uses sequences like, I will show you, .. but this is used in Linux, for instance, or an attacker can use .. in case that he is using a Windows operating system, okay? And this is used to move up the directory hierarchy, okay? Now, by chaining these sequences, so if you use .. you are chaining this one here to this one here. And by using these chaining sequences, they can navigate to parent directories and potentially access sensitive files outside the intended directory. Now, we can try this theory, okay? We can use this information to see if there is any file called root.txt on the root directory. Now, I think that this is the answer because when we were searching for the user's flag, the user's flag was saved in a file called user.txt, and that file was saved on a directory called roberts, okay? Now we can assume that the root's flag is saved in a file called root.txt under the root directory. So let's see, we need to execute our file once again. However, this time instead of inserting an A, for instance, we will insert .. and then we insert root.txt, like so. So the name of the file that we think that has our flag. Now, let me just tell you that we use one time .. and we do not use another .. because this allows us to move up from the reports, so from this directory here to the root directory, so to this directory here, okay? If you use this once, you will go from the reports to the root directory. So instead of trying to open the file that you inserted, so the file root.txt on the reports directory, this bug tracker executable file will try to open the root.txt file that you inserted on the root directory, okay? I hope I'm making sense, but if I'm not, please tell me in the commentary section down below. Now we click enter and let's see, and here we have it, guys, we have our flag. So we were right, our flag was saved on a file called root.txt and that file was inside of the root directory, okay? Guys, thanks for joining me on this journey through the Oopsie box from Hack the Box, and we have successfully navigated horizontal privilege escalation and exploited path traversal to find the root flag. If you enjoyed this video, please like and subscribe for more content, and feel free to leave a comment with any questions or suggestions for future boxes. Until next time, stay curious, stay safe, and happy hacking! Bye bye!